record. Yes, we're recording. Okay. So a couple of things that I wanted to show you that I have demonstrated here. I spoke to you guys about, I told you guys about external libraries. The Python has a lot of external libraries. Now, I haven't really talked about virtual environments. I think I'll find time to talk about it. So this is a virtual environment. Basically, it's like a new PC, right? Like a new computer, new operating system that is designed only for Python. Okay. So it's this Python, this one is separate from the normal Python you have on it's separate from anything you install here. Is not actually installed on the machine, it's just installed on that virtual environment. Anyway, so from randint, so let me just explain the code one more time. So from the random class, from the random class, right? I haven't explained classes, but anyway, from the random class, we imported randint, right? The method or the function. And what this function does, okay, is that it takes two parameters, the lower value and the upper value, okay? So if you check it, to tell you, it takes two integers. It can take more. It's a function. So yeah, the randint function. It takes in two parameters, two integers. Okay, so if you put a float or a string in it, it will give you an error. Now, and then it will return an integer. Okay, so it takes in two integers, returns an integer. So what we are doing is that we are rolling a die, right? We want it to give us a random value from one, between one or from 1 to 6, to pick a random value between any of them, or from 1 to 6 to pick a random value. Now, because I can't be guessing, yeah, that's not the point of the whole thing, because like I can actually become a long thing guessing, right? I just wanted it to print the results for me so that I can actually get it wrong on, I can get it wrong on purpose on it. Then here, the console is activated and I can enter my inputs. Okay, so I input a number, any number between 1 and 6, right? Now, I'll update the code in a bit. Okay, so yeah, okay. So what I want, okay, so I input my guess, and so see, so as we keep learning, we keep updating our code. Okay, so we enter our guess. So after we enter our guess, what happens next? It will check if what we rolled and what we guessed are the same. If they are the same, then it will say that sure, you got it right, or you got it right. If they are not the same, it will tell you didn't get it right, and to tell you what the actual rule was. Okay. Now, I can use the if condition to account for the situation where the person, okay, enters a number that is 1 greater than 6 or less than 1. To give him an error. So this is where the nested ifs come in. So you put an if within an if. So I'll just create a structure. I'll say that if, this is my battery percentage. If what's if your user guess, sorry about that. Okay. If your user guess, right, is less than 1, or we need one of these. If at least one of these is true, it should run our error for us. So, or our user guess is greater than, so is greater than 6. What do we want to happen? We want it to print that, okay, right? We want it to say that print this one, this nested if I'll try it in a different way, right? So we want it to say that print you entered a wrong value. Hmm. Okay. Okay. You see, with programming, okay, there are certain things that are designed to make the code easier. So here I would have run a loop, okay, if he entered the wrong value, for the code to start automatically again for him to enter his value. But because I'm using only conditionals, I'm very, very limited here. But still we can make our point. So what I'll do is that I'll type the else condition, right? And then I'll place this line of code by using the tab within my else condition, right? So this if and this else, this one, this block is nested under the else. So we can just go ahead and check. We can run our code. Sorry, you see, I didn't put my colon there, so it gives me the error, right? It tells us a syntax error because that's the syntax of the if, the language. So my guess is 3. If I enter 10, it will tell me that I entered the wrong value because it checked. Did I enter anything greater than 6? Did I enter anything greater than 1? It checked. Then it input, since it could tell I entered something greater than 6, it threw me this error, right? If I run it again, right, and then I enter -1, it will tell me I entered the wrong value. So let's try and get it wrong, but the good kind of wrong. So let me put 3 here. So it comes, so it checks. Did he enter a value between or greater than, less than 1 or greater than 6? No. So this is false. Okay. So once this condition or these two conditions are not met, this is not true. This is not true. You see, for the or case, at least one must be true. This is not true, and this is not true. Then it will skip the if and come to the else. Then to check, okay, else, what is here? So what value did he actually enter? Okay, is it correct? Yeah, you got it. Then it will come and say that, okay, the actual row was not equal to the user guess. So it will skip this if also, then come and run this else. Please, I hope you are getting me. I'm recording it, so if you have any questions, I'm just trying to explain what we did. So the nested, okay, so the nested scenario. All I'm saying under the nested, okay, is that we can put certain if blocks under if or else blocks, okay. Okay, so yeah. So how can we improve our code again with what we've learned? So um let me see, let me see, let me see, let me see, let me see. So we're just trying out things. If you have any ideas, you can just raise your hand, then we talk about it. We see how we can implement it in code. I ask you guys a question that can anything be solved with code? And you're like, some yes, some no. It depends. Anyway, so here it's a simple game. We imported the random from the random class. We imported the rand int function, right? And then from the random class, we imported the rand int function, and then with the rand int function, the rand int function takes two parameters, the two integers, and returns an integer, right? And then yeah, basically that. So let's try something involving else if to try and improve our code. So right now we have a situation where if the value is between hmm, is between so let's okay, so let's use two dice. Okay, so let's call let's call this first row, right? Let's change the name from actual row to first row, and let's change this one to second row. Second row, same thing. It takes the round int function, and then you need to type the whole thing out. One, oops, right? So int first row, then comma second row. Okay. So I have my guess. Okay, my guess will be a sum of these two values. Okay. So let's create a variable called sum. Okay. So sum is basically first row plus second row. Okay. So we are adding whatever we got here with this and this. Okay. Now, what do we want to do? We want to say that, and this is where we can use our else if. So I can comment out this code, meaning that the interpreter will not try and execute anything have um, the hash or the pound sign in front of. Okay, so I can say that if right, if the output of sum right is greater than um if your output is less than 5, right? Let's try and be a bit mystical here. Let's tell the user that he's going to have you're going to have an unlucky day, right? Then we try the else if. So elif, right? So we have another condition. So if my sum, right, is so here we can. So that's something. This thing is basically like math. So if my sum is between 5, what's it? Between 5 and 8, right? If my sum is between 5 and 8, right? When it's gonna rain, it's gonna rain, okay? The maximum value is 12, obviously. So another elif. As I said, you can have as many elifs as you like, whatever makes you happy. So if it's between 8 and um, 11 or 4 to 11, then tell him that print print what's it? Print yeah, and this thing I'll treat it, maybe implement it. Print print you're almost lucky. Let me see how many people are on this call. Okay, print you're almost lucky. I'm just trying to demonstrate the elephant. Then else is just going to be the last possible case. Print your luck lagged. Right. Don't need to really read much into. So my guess is that I want. Uh, my guess doesn't really even matter. So so what happened? So it took the two of them and summed them. Okay. I think this line is not really relevant. This line is not necessary, right? So you roll the two dice, okay, of the die or whatever. You roll the two of them, and then you added it up to 5, right? And then you checked. Okay, so now somebody will be like, why is it that the reason why it's behaving like that, okay, is because I never actually accounted for 5 in the code. So both 5 and 8 are not accounted for. Okay, so I can just say that or equal to 5. So I can just say that less than or equal to 5 can say that or equal to 8, right? So let me rerun the same script. 8, it's gonna rain. But if I run the code again, it's gonna rain. This one, I'm just checking my luck. I'm almost lucky. I'm almost lucky. I'm going to have an unlucky day. I'm almost lucky. I'm going to have an unlucky day. So this one, the condition where I get my luck magnets. Oh. So about rerun. I'm running the things too many times anyway. So that is how the ellipse works. So we accounted for our first true condition, our second true condition, our third true condition, and then any other condition which we didn't account for in the first three conditions. Okay, so please, do you have any questions? And one more thing, okay, you can actually set a variable to true, true, okay. Can actually set a variable to true. Okay. Um, I wanted you to try something while you're there. One thing to note is that the else doesn't take a condition. Okay, it just runs every other condition that is not captured in the true condition. So yeah, you can actually store that's a Boolean variable. Yeah. You can actually store expressions as Boolean variables as or Boolean states as variables. So to tell whether the thing is true or false. Yeah. So this is how I want us to study, right? So we try and build something. So please, I'm open, I'm all ears. Do you have anything? I want us to build one last thing because I've explained everything I can at this point. Because we can do that's the thing, we can do more when we find out more. So next week we'll be talking about loops. Okay, so there's this famous sequence in mathematics, the Fibonacci, right? So basically you sum the first two numbers, then it gives you the next number. You keep summing, you can sum the Fibonacci till infinity, right? So the Fibonacci doesn't technically terminate. But anyway, yeah, we can do that when we talk about loops. You see, we cannot iterate. So the loop allows us to iterate a lot of times, right? Yeah, we'll talk about all that next week, right? Probably Tuesday or Wednesday. Next week, I want us to meet on Wednesday and Saturday instead. I think that'll be a better time. Wednesday in the evening, Saturday in the afternoon. Okay, let's recording this class also. So please, yeah, I'm waiting for you. Just I want somebody to anything you want us to build, anything that's been tickling your mind in your life. I would like a programmatical solution or a coding-based solution to this. Let's try and see if we can resolve it with only if what we know so far, we know so far about the if, errors, some libraries, some functions. Let's see if we know and with what we know we can do something about it. So I'm waiting. Let me give a minute for somebody to say something. Else we end the class. Okay, there's this one more data type. It's not particularly a data type, but it's I don't know whether okay, I think I can use the remainder of the time to talk about it. Arrays. Okay. Now, I think next week we'll treat arrays um in all its forms, dictionaries, lists, sets, tuples, and then the loops. Okay, so we'll take arrays because arrays are very, very important. Arrays allow us to deal with a bunch of data. Okay, so when you have a variable, when you have like a situation where X is not only equal to 1, but X is equal to 1, 2, 3, 4, 5. See so many things at once. So maybe you have people's age. Okay, people keep entering their age, and then you get me. So you see those things you do in primary school where you have the table and then you have marks and then you do the tally and all those things. So something like that. So there are the data is a data set. Okay, not just one single um, we put a lot of things into one container. So be able to identify what a dictionary is. So basically we group them into list, dictionary, set, and tuples. So we look at all of those things. So all of them are kind of data types. Like they all have different different properties. Okay, we'll look at all of them next week. I don't think I actually forgot that, but yeah, if we look at all of them next week because it's very, very important because when you start handling a lot of data at a time, you will need to be able to take in all the data, right? And run something on them or run an action on them at once, not taking them one by one and running it just all at once, running all at once. So please, do you have any questions? The title of this one would be Conditionals 2. The title of the other ones was Conditionals 1. I just want somebody to say something, any program they want us to build. Because I want something that is from us so that when we build it together, it sticks better. So a minute, I'm giving you 1 minute. If nobody can come up with anything, I think we'll end the class there because it's quite late. It's practically 10. Uh, mm. So while you are thinking, yeah, programming like any endeavor in life, you just need persistence, consistency, and trying more stuff. Just try and use it in um, your daily tasks. Okay, they give you homework. Just try and use programming to solve it. Like, uh, um, try and, or if you get what I'm saying, try and use programming to solve it. Because programming is designed, okay, to leverage the computing power and intelligence or the speed of the computer to run complex or work that would be too tedious for the human being. Okay, so like you don't need to take a calculator. Like that's like you see how calculators have basically when you cross a point, you enter SS, you don't need to use your mind to compute the value of root 3. Yeah, if you do electrical engineering, you know it's at the 1.7 or 1.5 something. I don't remember it. But because we use it all the time. But the point is you don't need to calculate it. Like there are things that are there designed to help you because you see the value of the three is not what we are focused on. We are focused on something bigger. So these things is just so we can abstract that. We can say you let the calculator find the value of three and use that to get us what we actually want. So that's the same thing. Like let the computer do the hard work and you reap the fruit. So just try and find any hard work in your environment, in your class, in your school. Yeah, then let the computer do its work. Okay, so since nobody has um since nobody has I think I'm going to give you a quite tricky one. I think I'm thinking about it right now. A puzzle. Okay. Hmm. But it involves an array. And I haven't taught you guys array. So the idea was that okay, um, it will randomly find numbers from 1 to 10 or from 1 to 100, 10 different random numbers, right? And then you have to that would be too hard. That would be too hard. So basically, I gave you guys an assignment the last time, right? On if statements. I think I remember that. So yeah, I think we'll end the class here. Okay. We'll continue next week. So if you have any questions, and try out some project to do. Well, okay, tomorrow in the afternoon, I'll post a project in the group that you should try based on the just conditional statements. Okay. So tomorrow I'll post it like around 12 or something. So I presume I'll be free in the afternoon. Not for a long period, but free enough to upload the assignment. So yeah, I'll be ending the class here. Do you have any questions or you're all okay? So since there's no response, no reply, I presume everybody's fine. And so have a good evening. Yeah, we'll continue next week. Okay, so, and one before I end, this is a pillar of programming: conditions, conditional statements. If condition is met, we want an action to be run, else run this instead. Okay, so, yeah, have a great evening and I'll see you. You can text if you're call if you have any issues. Yeah, good night.